So I got a comment asking about disintegrate materials, and I decided that the resource that I sent the person wasn't really satisfactory, so I wanted to take my own crack at it to see what I could come up with. All that stuff in the boxes is just for teaching purposes, but it's really simple. The inputs are a base color that's just 50% visual gray, an emissive, and an opacity mask here. So let's start from the top. Okay, actually, let's do it with one channel, because 2 channels is going to get really confusing really fast. So let's do top to bottom, 0 to 1. And let's start, let's start with explaining what this is. So this square, let's just call it a line from 0 to 1, and what it outputs is a float value. So it could be, and a float is just a number that is between, or excuse me, not between anything, but rather it can hold a decimal place value. It could be 1, but there's a potential for it to be 1.1, for example. And there's also signed floats that can be negative, but we're just going to focus on the positive range. So, for example, this holds 0, 0.1, 0.2, 0.5, all the way up to 1. Let's explain ceiling and floor first, because those are really simple. So as you can see, ceiling outputs 1 and floor outputs 0. So what these are doing is they're taking all of the float values and rounding them up or down. Obviously ceiling goes up, floor goes down, but it's rounding them down to the nearest integer. And if you need a refresher, integer is just a whole number without any decimals. So the next thing I'll explain. Oh, actually, let's do one extra bit here. Let's add a number to this. And obviously, it's going to output white now, but let's just add 0.5. Or let's add 0.2. Okay. So what you can see here is everything that went. Basically what we did is we shifted this entire gradient upwards by 0.2. So this line here is where 1 exists, and this white area is everything that's above the value of 1, and everything in the black is a value that's below 1, and that's getting crushed back down to 0. So the next thing I want to show is frac. And fraction takes all of the integers off of float values, essentially. So you're only left with the decimal value. You won't really see any change here. Wish that updated a little bit faster there. So, but what I can do is multiply. Let me close that for a second. If I multiply these values by 3, for example, what you'll see is it kind of just looks like everything from 2/3 on is pure white, and then there's just the gradient getting crushed up to the top. And this is because we can't display any values greater than 1 or less than 0, so those just display as black and white. But what frac does, as you can see, it takes all of the integer values, so now we're just getting 3 gradients. So this is the 0 to 0.9999 range, repeating 3 times. And so of course this can happen in 2 channels. Not that this is particularly relevant to what I'm going to show you, but just for example, you can have a tiling texture coordinate. Not particularly useful. I suppose if you had mirrored or clamped UVs, then you could do something with this if you really needed tiling, but that's a really weird edge case. and just to show you, it can work in 2 channels separately. So that's a 3x5. Anyway, let's move on to the next one. Frac and time scale. So, oh right, so time just outputs a float going from 0, just keeps going forward. It never clamps or anything. Eventually it does run out of decimal spots, so after a very long amount of time you'll sort of run out of data, but it's totally fine. We're just using that for demonstration purposes. So what I'm doing here, let's multiply this by, hold on, let me preview this node. Here we go. So what I'm doing here is taking time, and let's also set this to 1. And I'm just adding a flat value. You can see, well, here, let's frac. So I'm just adding a flat value from 0 to 1, and then when it hits 1, it goes back down to 0 and starts over again. And so what the effect is we're getting here is that we're shifting the entire graph. This red line is where this gray line is supposed to be, and we're just adding on top of every value in the graph all at once. If we want to slow it down, we can just scale time by a value here, and because the frac is at the end, it'll still work all the same. So I'm going to move on to if and 1 minus x. Okay, well, so much for doing this in one take. Now I'm going to explain how if works. We're on if and 1 minus x. But before I do that, I just want to explain what this burn parameter does. Now, for the purposes of this, we just want to play an animation that goes from 0 to 1, 0 being 0% of the paper is burned, and 1 meaning that the entire paper is burned. So what our if statement is going to do is evaluate the how far the burn has progressed from 0 to 1, and then output a mask for the opacity of the paper. Excuse me. So basically what if does is it takes in A and B, and right now A is just a gradient from 0 to 1, and B is our animation variable, and then it outputs something based on these 3 rules, which read, if A is greater than B, output, in our case, 1. If A is less than B, output 0. And if A is exactly equal to B, we want to output, and in this case, we want to output the opposite of B, or 1 minus B, to be precise. So why are we doing this special thing with A equals B? Well, if we switch over to the texture, we'll see that if the burn is all the way completed, oh, excuse me, so let's say we want A equals B to output 1. That works for every value except for when we get to exactly 1, and you'll see that some of the pixels in this map reach 1 and they kind of clamp. So we want the entire paper to burn away when the animation is complete. We don't want any scraps to be left, so that's no good. But if we output 0, the exact same problem will happen in the dark areas. If we're all the way 0, you can, whoa, I'm trying to zoom in here. You can see there's a tiny little spot of black here. Let me just power this so that it's a little easier to see. But you can see there's a, zoom is weird here. There's a bit of a dot. So when the animation is at 0, we want it to be 100% white. We don't want any scraps of it already burned. So in the resource that I sent the commenter, they use an entire extra if just to solve this one problem, but it's very simple. All you need to do is input the opposite of what the animation is. So what 1 minus does is it takes 1 and then it subtracts whatever you're putting into it. So 1 minus 0 equals 1. So if burn equals 0, we're going to get white. Essentially, what we're getting at 0, we're getting this, but at 1, we're 1 minus 1 equals 0. So it's like we have this one plugged in instead. And so that's what this is. That's the problem that this is trying to solve. So the next thing I want to show quickly is that I'm taking the same thing from up here, time with a scalar, and then Frac, just to show we've got an animation here that goes from 0 to 1, and then when it hits 1, it loops back around to 0. Okay, so the next thing we want to do, this looks pretty good, but we've got no control over the direction of it. So the next thing I want to show you is gradient mixing. Okay, so the next concept I want to go over is gradient mixing. Now this is basically the exact same setup from before, except the result we're getting this time is this. And you can see now it goes from top to bottom, and that's a pretty nice looking result. So how do we get that? I'm going to set this back to this for now. Well, basically what we're doing is, could have had this set up ahead of time, we're combining these two gradients. So we're combining the height map and then just a direction. So this is basically like the flow map for our burn, and this is the pattern. So what we're going to do is add them together. So the largest number on this is 1, and the largest number on this is 1, and the lowest number for both is 0. But what you need to understand is that when we add them both together and we get this, now the largest value is going to be 2 instead of 1. So that's why I'm multiplying it by 0.5, and that's just reducing the value range back into the 0 to 1 range instead of the 0 to 2 range. Now, if I wanted to have a larger degree of control over how I mix these, let's say, for example, well, hold on, let's play this again. So this is a 50-50 mix between both gradients. Let's say I want a more subtle distortion, and we really want it to kind of stay smooth and kept together. What I would want to do is multiply this. Essentially, what we're adding the two gradients together and then dividing by the number of gradients. So what I would do is, let's say I want 2 of these, and fun trivia fact, the reason I'm using green is because more information is stored in the green channel because of the way our eyes work. Computer programmers have given more data space to that channel. So anyway, now that I've added these together, I've got double the amount of linear gradients and only 1 noise texture. So this time, instead of multiplying by 0.5 is exactly the same as dividing by 2. But now that I've got 3 gradients, I'm just going to divide by 3. You're not really going to be able to tell a difference, but if I plug it in, now you can see it's a little bit more subtle. So let's say I want to add 3 gradients in. So I want to divide by 4. Well, let's bump it up a little bit more. So now you can see it stays really kept together. It's just got a little bit of subtle noise distortion instead of being quite so broken up. So this is how you control the flow of the burn. But for our purposes, we're just going to stick with the basic 50-50 because I like to have little islands. Okay, so now we're on seal instead of if. Now this was just a personal thing that I felt was a bit of an optimization trick because I'm already going to be animating the gradient anyway, and we'll get to that in a second. But I'm using this seal to replace the if statement above. Now, you may not necessarily want to do this. It kind of just depends on what results you get. But personally, I would recommend using the if statement because you do get that extra control over the value that you're outputting when A equals B. And I think that's pretty important. But for this, since it's just time looping, I think it's okay to just use seal for demonstration purposes. So anyway, the real thing we want to look at, though, is this gradient, because we want to add some visual interest to the edge of the disintegrate to make it look hot going to not hot. So we've got our flow, the two gradients that are combined, and then we've just got a time scaled by a speed run through Frac and then being subtracted. So Frac is just outputting 0 to 1, just a solid color. And so if you kind of think of this as a height map, it's kind of scanning through the height, if that makes sense. So just to demo that with the scalar parameter, when we're subtracting 0, we're just getting exactly this height input. If I do 0.5, that's halfway finished with the animation. And then if I subtract 1, then everything is going to be completely black. So before I move on to this psychedelic looking thing up in the corner here, I just want to quickly review the frac and floor concept. So what I've got here is a linear gradient, and I'm just multiplying it by a scalar value. So let's go ahead and do 2. And you'll see I'm going to get 2 gradients here, and I'm going to get a mask here where the bottom gradient is white and the top gradient is black. So if I scale this up higher, I'm going to get a bunch of gradients, but I'm only going to get one gradient. The first gradient is going to be black, and the second one is going to be white. So what we're going to do is use a 1 minus. We're just using this as a mask essentially, but we only want to take, I guess I should just multiply this. You'll see we only want to get that first gradient, and we're using that gradient to drive a color. And in the case of this psychedelic thing, we're using a 3-color blend, but we're actually not doing it like that. What we're doing is taking this and then multiplying it by this mask here so that we only get the top rainbow. So I hope that makes sense because it's about to get a little crazy. So I'm going to start previewing this again. And essentially what we've got here is the flow map from earlier, and we've got the animation in our subtract, and we're using this gradient parameter to scale up or scale down the gradient. So if I do it at 1, this is just a single copy of the gradient with no masking because it's just all white all the time. But if I set it to 3, you'll see that this black and white mask starts to kick in, and what it's doing is it's essentially the black part is because this multiply here is representing our emissive. Black is going to be every area that we don't want to be lit up at all, and we're using this ceiling here is going to be our opacity mask. So anything in the black in this opacity mask will have burned away and we won't see it. So as you can see, when we multiply, when we multiply these two together, we only get one copy of the gradient where the black here has burned away, and the black on this part of the texture is representing unemissive parts of the texture paper. It's important we do it this way, and hopefully you'll see when we get to the end. Alright, so essentially what we've got here is the exact same thing as above, but instead of using lerps to get our color, we're using a node called Blackbody. I'm not going to attempt to explain this right now. We're going to do that at the end, just because everything is separated out nice and neat. But I will demonstrate how Blackbody works over here on its own, just so that you can understand the concept. Now, just on its own, let me start previewing this. Blackbody can just take in a scalar value and output a color. So if I lower this, now I've got a little orange, and you can see the higher the temperature goes until it gets really emissive. So I think, what was that at? 32, I think it was at 32,000, or 3,200 rather. But let's take our texture and multiply it by the gradient. And what this does is it allows us to get a naturalistic fall off of the values. So we've got these dark reds here and these hot yellows. So essentially the gradient is going to act as a heat map. And if I can go back to this for just a little bit, there's two options here. Now, well, hold on real quick. Let me take this mask, because it's going to get a little confusing. And let me, all right, this is going to look bad, but let me go ahead and add a small value, just so that we can differentiate between burned up and paper. So paper is going to be gray and burned up is going to be black. Now, what I've got here is a hot leading edge and fall off to cold. But you might also want to use 1- to flip the gradient. And now we've the edge right before it disappears is the hottest, and we've got it colder where it leads towards the paper. And that's what I'm doing below. Obviously, do whatever you want to do, whatever you think looks good. I'm just trying to explain the concept. So this is the final result, and as I said before, we've got 50% visual gray just for the base color so that we can differentiate between paper and not paper. And we've combined all of the things I taught above to make our animation look right. And then one final thing I have here is, since this time node is just for to have a looping animation when we work, the final thing you're going to want to use is a parameter that controls the burn. And there's a small fix that you need to apply if you're using sealing. Now, if you're going to be using if you don't need to do any of that because that's built into the A equals B. But since I decided to go with sealing, I'm whenever burn equals 0, or rather, whenever burn is anything above 0, as you can see at the right here, I've got a tiny little snippet of heat, but because 0 doesn't get rounded up to 1. I'm multiplying it by 0. But as soon as this goes slightly over 0, that means that the animation has begun, and then we're just going to ceiling that all the way to 1, and that's going to allow the emissive color to show through. So you can either use that, or if you think it is easier to understand, you can just use an if statement. It's only a few instructions cheaper, I think, to do it this way, so it's not really important. But as you can see, as we scrub through this animation, it will complete until we get to 0. And if I want to adjust the gradient, say 1, that'll be a very large gradient. Or if I want it to be super tight, we can get it dialed in whatever we think looks the best. So I hope this was helpful for you. Let me know in the comments.